you're watching this video, you missed the first part of the lesson because I forgot to turn on the video. This is still Math 10. That's all it is. It's a good review. We're just practicing our factoring for Math 10 so that we're ready for our Math 20 level factoring. Our Math 20 level factoring is going to get a little bit more difficult in a couple different ways. The first way it's going to get different is we're going to start to add in numbers that are a little bit harder, a little more challenging. My smartboard has stopped working. So you'll notice on the next question it should be decimals. Right? So if you look at that, it's x squared plus 1.4x minus 1.2. So that's a little bit more challenging just because of the decimals. Does everyone recognize that that's going to be more challenging? Yeah, that's not a shock to anyone, right? Yeah, that's going to be more difficult. And if you tried to set that up for a diamond, let's do it just for fun. Don't write it down. We're just going to look at what this is going to look like. We're going to need things that multiply to be negative 1.2, add to be 1.4. That's a terrible thing. That is going to be one hell of a diamond to try to solve. Things that multiply to be 1.2, I got no idea. Outside of 1 and 1.2, I have no idea what multiplies to be 1.2. So I'm not going to be able to solve this thing. There's no way. So my rule for this class is that when you see something that looks too challenging in this unit, find a way to make it not challenging. That's my trick. We're going to take everything in Math 20-1 and we're going to change it to be like Math 10C. So what was hard about this question again? The decimals. So we're going to figure out a way to get rid of those decimals. What we're going to do is we're going to multiply everything by a number to get rid of that decimal. So if I wanted to get rid of 0.4 or 0.2, what's a number I could multiply both of those by that would make it a whole number so that it's no longer a decimal? 10 would definitely work. If I multiply everything by 10, it just moves the decimal place 1 over, correct? 10 would work. There's a better number that works. 5 would also work. And the reason I say 5 is a better number is it's a smaller number. The smallest number you can choose that works, the better. 10 would still work, 5 would still work, both would be just fine. I always choose the smallest one. And the reason that 5 works is because the decimals are even decimals. So if you multiply 4 by 5, it's going to work out for you. If you multiply the 2 by 5, it's going to work out for you. That's going to be 20, that's going to be 10. Right? So it gets rid of that decimal.
If you use 10 instead of 5, would you just have to reduce at the end?
Yeah, that's all it's going to change. It's going to have to do a little reduction at the end. So what we're going to do is we're going to make this question easier. We're going to multiply everything by 5. So times by 5, times by 5, times by 5. Yeah, kids. Oh, no, not right now. Thank you. So if we multiply everything by 5, I now have 5x squared plus 5 times 1.4, 7x. 1.2 times 5? Yeah. Amazing. That is a Math 10C level question. Everyone in this room can do that. You've been doing it for 2 days. So we took something difficult, we found a way to make it easy. And we're going to do that over and over and over again. The only thing you need to do is, you can't just multiply things without balancing them out. Right? There's got to be some sort of balance here. So what we do is, we put this in brackets. And because we multiplied by 5, we're going to also multiply by 1 divided by 5. And that's just our way of balancing the scales. Like, I can't take something, multiply it all by 5, and think that it's still going to be the same thing. That make sense? So all this 1 over 5 is doing is it's balancing out that multiplication by 5 that I did. Yeah.
Whatever you use, so say if you multiply by 6 instead, it'd be 1 over 6.
It'd be 1 over 6. Yeah, if I multiplied by 10, it would be 1 over 10. So you're just balancing out what you did to make it easier. Yes.
Okay, so putting a fraction in, that's not the same as just putting a bracket by 5, right?
You would actually be correct to do that. It's just not going to look like that. They would write it out here. That's just a different way it would look. But you would be, like, if you wrote it all divided by 5, that's the same thing as saying 1 over 5 times. It's the same thing. Just a different way of writing it. Is everyone good with me pulling that 1 over 5 out and balancing it? Awesome. Now, we've got a trinomial on the inside. Factor that thing. So it's just a math 10C question. You're going to set your diamond up. The top of the diamond is going to be negative 30. The bottom of the diamond is going to be 7. Things that multiply to be negative 30 and add to be 7 are 10 and negative 3. We set up our brackets. We know we're going to have 5x. And then we know we're going to have 5x again. That 1 over 5, remember that thing I had to balance?
Stays out.
It's still out full. It's just constantly sitting there to balance what we did at the beginning. My last step, I know I don't need 5x twice, right? That doesn't make sense. So I got to divide one of them by 5x. Just 5, sorry. I'm going to add that first. Took a concept that looked a lot more challenging, we balanced it out to make it look a lot easier, and then we solved it just like we solved them for a whole year. That's going to be the theme of this unit. I'm going to say, take something hard, find a way to make it easy. So if we look at question B, what makes question B so hard? Fraction. The fraction. This fraction right here makes that thing look a heck of a lot more challenging to us. So how do you think I could get rid of that fraction if kills? You could change it to a decimal, but then a decimal is going to be hard too, right? What's another way you can get rid of a fraction, right? Multiply it all by 2. You multiply everything in here by 2, fraction's going to be gone. That's how we're going to make it easier. We're going to get rid of this fraction by multiplying everything by 2.
Would the first one be 6x to the power of 4 now?
Yeah. Oh, no, sorry. It would be 6x to the power of 2. So it only goes to the coefficients. So if I'm multiplying everything by 2, this becomes 6x squared. This thing becomes 29x. Right? The 2 canceled out on the bottom. It got rid of our fraction for us. And then it became plus 28. We took something challenging, we found a way to make it easier.
Do we need to put anything up front?
Yeah. What do we need to put up front, do you think?
A 1 over 2.
A 1 over 2. You can't just do something without having some sort of balance in there. So if I multiplied everything by 2, then I need to multiply everything by 1 over 2 to balance out what we did. Stuff on the inside. You can factor that. So go ahead, try to factor it on your own. So the stuff inside the brackets, you try to factor it out. Give it a shot. It's going to be a challenging one, that's why I want you to try it. Because you're going to be finding things that multiply to be something really big. Like really big.
There's no fast way to find the 2 sides.
There's no fast way. Nope. You're going to have to probably make a chart, or maybe use some good guesstimation skills. Like for instance, so if you do that chart on the side, you notice that it's negative 8, negative 21. The only way to do that is to really checking and guessing. So I'll start guessing and checking. Checking and guessing. You set up your stuff on the side, so 1 over 2 is still up front. You have a 6x minus 8, then you have a 6x minus 21. Try to finish that off. You should get 3x minus 4, and 2x minus, because it was a negative 8 and a negative 21. That's not much more challenging than yesterday. It's not. It's one extra step. That's all we had to do. Took something hard, found a way to make it easy, make it a 10C level question. Y'all passed 10C, that's how you got here. And there's no way you passed 10C level without that. Man, but you did it.
66.
Start from the bottom right here. Okay. We got 2 practice questions here. I want you to try both of them on your own. How are we going to make this first one easier? Times by 2 would work perfectly. Because a 0.5 times 2 is going to make that a nice round number. Another 0.5 times 2 is going to make it a nice round number. Yeah. Yeah, it's any way to make them equal to 0. So if you imagine like 5, I want to somehow make that like something 0. So if I want to make it 10, right? Like how can I get 5 to be 10? 5 times by 2. That's why if you had like the 0.4s, I want to somehow make that equal. I want that 4 to be equal to 10 or 20 or 30 or 40 or 50. So if I times by 5, it would give me 20. Now if you had something like 0.3, the only way I'm going to get that to be a 10 times by 10, yeah. They 2, 5, and 10 will be your most common situations you run into. And like I said, 10 would always work. It's just it's going to make it a little more challenging because you're going to have to take out a number at the end. Because you'll have a GCF, you'll have an extra GCF. So,
squared times 2x.
Times 2 is just 2x squared. Yeah. So go ahead and try all of these on your own. So that first one we made easier by multiplying by 2. Made it a nice little trinomial. Remember to put your 1/2 out front, right? You're balancing it out.
Nice little trinomial.
You have your little trinomial. It's an easy one to solve. You pumped it out. It looks like that. The next one, we had to multiply by 3. Right? Whatever's on the bottom of the fraction, that's what I'm multiplying by. Things that people mess up. They either multiply this 3 by this 17, and they end up having a number that's too big. You did that, see? Or they forget to multiply it right here as well. Sometimes people forget that you should do a 3 times the 1 in front of that x squared. So it becomes a 3x squared. So those are some common things people mess up on.
What if you have a fraction decimal?
Then you'd have to find a number that would get rid of both at the same time. I don't think that's going to happen to you.
Would it usually just be the fraction?
It's usually just a fraction, yeah. You might end up having a fraction where it's 2 different numbers on the bottom of the fraction. So, for instance, maybe it's a 3 and a 6. So then if you multiply both things by 3, it wouldn't work. But if you multiply both things by 6, it would work. And so sometimes they'll have multiple fractions. We'll see if there's questions like that in your practice booklet. If you ever run into it, then you can ask. I'm pretty sure this is as hard as it gets.
How would the 6 cancel out?
If you multiply by 6, 6 divided by 3 is 2. So you'd have to multiply the top number by 2. Like it would cancel, but it wouldn't. It's like doing a lowest common denominator is what it's like doing. Let's just pray. Let's pray there's no more denominators in the future. Okay. Question 8. Look at that question. Is there something that makes that question difficult?
No.
No. So we don't have to do any of those questions. We're just going to dive in method it. Negative 16 on the top, negative 6 on the bottom. We're going to go negative 8 and 2. The question is just x minus 8x plus 2. Nice and basic. Reminding ourselves that doing things sometimes can be nice and simple, and that's what our goal is always to make these things nice and simple. Now what I do want you to look at, notice, just give me a second to write that down, is what a trinomial looks like. Sometimes we take that for granted. Our trinomial is something squared times that same something, and then there's none of those something. We don't know what x is, but it was squared in the first term, it existed in the second term, and then it was gone in the third term. If you look at question B, question B looks like something we've never done before. But in reality, it's absolutely something we've done before. Look at this thing. It's something squared. Then it's that same something. And then there's none of those somethings left. It's just that something has become a binomial. So it's just a little more challenging. But in reality, these are the exact same types of questions. This is still a trinomial, which means we can still factor it. But we can't factor it with the way that it looks, because that's too challenging, right? It's too hard, it looks hard, so we need to find a way to make it easy. What I'm going to do is I'm going to substitute a different lettering for x plus 3. I'm going to say on the side over here, I'm going to say, well, x plus 3, we're just going to call that y. We're going to say anywhere I see an x plus 3, I'm going to call it y. So this question becomes y squared minus 6y minus 16. And now that looks like something I can factor. So I took something hard, I identified the thing making it hard is the binomial, and I changed it to make it easier.
Why wouldn't you just put your exponent into your bracket?
If you try to expand that thing, now you're going to have like a massive thing, right? Because this is going to create 4 more terms, this is going to create 2 more terms, and now I'm going to have like a massive mess on my hand. It's going to be a 6 plus 4 is 10. It's going to be an 11-term polynomial with a lot of extras that need to be added together. It's doable. It's just going to be a lot of work. Did you try it?
Yeah.
Yeah. How big was your question getting?
It wasn't even that big.
It should have been up with 11
I had
terms.
x squared plus 3
No,
minus 6x.
You should have x squared plus 3x plus 3x plus 9. Remember a binomial squared? You have to do 2 of them.
Oh, right.
And FOIL. So that's why it gets so big so fast. Yeah.
So you just do that, and then when you get the answer, that's the answer.
So I'll show you how that works. So I'm calling x plus 3y. Correct? Everyone's good with that? I got you.
Thanks.
Is everybody good with that substitution?
Yes, but if it was like, for example, like x plus 6, you could still call it y.
I can just call it y. Yeah. And we're going to do a couple of these. All right, if you look, these are actually the exact same questions. So I know this thing's going to factor to become y minus 8, y plus 2. It's the exact same question as the one above, so I know it had to factor to be the same thing. It's just a y instead. Here's where it gets a little bit challenging. So I replaced x plus 3 with y's. My answer always needs to be in terms of the same letters. So I need to change these y's back into x plus 6's now. So I'm going to go replace my y's back with my x plus 3's. I'm going to change it back. So now I'm going to have x plus 6 minus 8, and I'm going to have x plus 6.
You mean 3?
Yeah, sorry. So let's say it was 6 earlier question. It's now the second one. X plus 3. And then, so notice that all I did was I took my y's and I changed them back into x plus 3's. I'm turning them back. At this stage, I still have 2 binomials, these big brackets. I'm going to make them blue so they stick out. I can collect like terms within those blue brackets. So x plus 3 minus 8, which is simplified to be, do this up. It's simplified to be x minus 5.
But since it's in a different
Plus
set
3 minus 8 combined to be minus 5.
since it's in a different set of brackets, don't you have to like multiply it in?
No, so over here, oh, that's what you're saying. If the 8 had been on the other side, like touching it, then I would have to multiply it.
Oh,
But it's saying
so it has
this
a subtraction.
Exactly, this is subtraction sign right here. This one, collect my like terms again, I'm going to be left with x, and then plus 5. That's what this thing factors to become. So that one's definitely more challenging. That's definitely the hardest that it gets. Well, second hardest that it gets.
You said that about
But
the
that
last thing.
concept is the same concept. It's the hardest concept we do when it comes to factoring. You take a binomial, you replace it with a new letter. You now factor it because it's a simple one, but then you have to turn it back into the same letter you started with. Right.
So could you just, feels like, I don't know if this will work for every question, but if you have like negative 8, and you add 3, you get negative 5.
Yep.
And if you have 2, you add 3, you get positive 5. So you just add.
That's what I did. I checked my like terms.
Yeah, but before you draw those brackets out, you just add those numbers that were.
Yeah, I only drew the brackets to make sure it was obvious that this is all together and this is all together. That's why I drew those brackets in blue, just to really stick out that this is one thing together, this is another thing together. So if you don't want to like do that, that's fine.
But like on the next question though, like where it's like.
Okay, redo it again. Okay, so let me work through the next one. Any other questions with this one? All right. These are the questions that get as hard as they possibly can. So, if we look at question A, the first one, what makes that trinomial so difficult? Yes. The coefficient, yeah, but we're used to coefficients. We're not used to these brackets, right? So how can we get rid of these things? We change them to a different letter. We say 3x minus 4 equals y. And now we go into this question and we change anything that's 3x minus 4 to just be a y. I substitute out those binomials to be something easier, something I'm used to. I make a hard question easy. Now I can begin factoring. Which, how many people are ahead of me right now? Much. How many people started diamond methoding before they took their GCF out?
I did.
Yeah, a whole bunch of you guys. Remember, even in basic factoring, you gotta do your GCF first. It's your first step to every question once you start factoring. I need to take a 3 out here. Right? So the 3 comes out, and I'm 2y squared minus 7y plus. You're not the only one. There's a whole lot here. Now I can diamond method because there's no GCFs left in there. So I'm going to diamond that. I want things that multiply with 10, add with negative 7, and negative 5, negative 2. 2y minus 5, 2y minus 2. I have to divide the one on the right by 2. 3, 2y minus 5, y minus 4. Okay, so I took my question. It was a hard question because I had binomial squared and the same binomial. So I replaced that binomial with just y because I know how to do single letters. I know what's going on there. I then took a GCF out. I then diamond methoded it. And I did all that proper, so I'm here now. Now what's my last step got to do?
Change it back.
Change it back, right? If I started with x's, I need to finish with x's. You can't change what letter's there as your answer. So anywhere I see y, I'm going to replace it with a 3x minus 4. Go ahead, we're going to have 3, and I'm going to have 2 bracket 3x minus 4. Minus 5. I want to just take a look at how I wrote that thing out. So I put bracket 2, and then when I replaced my y, I put bracket 3x minus 4 bracket. And then there's a minus 5 after it. Okay.
Have it squared.
So right here, when I'm factoring, I put y and y. So if I were to ever multiply those back, it would create my y squared. Yeah. My next one, I'm going to go bracket, and anywhere I see a y, I'm changing it. So it's 3x minus 4 minus 1. Those brackets are important. There's a reason I wrote them out. There's a reason I want you to stop and notice how I wrote this thing out. Because in my first big set of brackets, I can't just simply collect like terms. I can't just bring them together. And the reason why is there's a 2 outside this bracket that need to come in first. And then I can collect my like terms.
So when it's front, it has to go in, but when it's back, it doesn't.
Bingo. So if there's a number touching it, it has to come in. If there's something separating them, it doesn't have to come in. I'm going to scroll this up. So if I multiply that 2 in, I still have a 3 out front. I got big bracket. I have 6x minus 8 minus 5 is still empty. This one, I can just collect like terms on that one because there's nothing to multiply in to the little brackets. In the first set of brackets, now I can collect my like terms. My minus 8, my minus 5 can come together. I got 3, 6x minus 13, 3x minus 7. That's how that thing would look completely factored. That's as hard as it gets. So that's the hardest type of factoring you probably will do. No.
So, like, are those questions going to be, like, all the time? Or is it just, like, every once in a while to get out of those questions?
Not all the time, but they will pop up every once in a while. Yeah. You won't see a lot of them, but you will see them.
Okay. That's a good second question.
All right. This one right here. Want to walk through it together one more time? Yeah, I see some dots. Okay. So I look at this question. I go to factor it, because that's what the question says to do. I look at this thing and I realize it's binomial squared, same binomial, no binomial there. So I want to change that thing to be something I'm more comfortable with. So I write down on the side, I write x minus 6 is called y now. And anywhere I see an x minus 6, I'm going to change that thing to be a y. Now that's a question I'm used to looking at. So I took a hard question, made it easy. When I go to factor that, that's my first step. GCF. So take your 2 out. And then we have a trinomial that we're going to start with. Hey, remember, GCF, always check for that thing. It is there a lot of the time. If I set up my diamond, things that multiply to be negative 24, add to be positive 5, is 8 and negative 3. My 2 still up front. I have a y plus 8. I have a y minus 3. I promise you that on a unit test, we're going to have a unit test eventually, there'll be a question like this. Now, I'll guarantee you that that is one of the options for an answer. Guarantee it. What do I have to do as my last step? Change it back, right? Change those y's back into x's. I guarantee you this will be an option. It's not the right option. You have to put those y's back into the x minus 6. And I always use brackets because it's a good habit to get into, just in case there is something I need to multiply in, I don't forget about it. In this case, I don't have to multiply anything in, right? I can just collect my like terms. So in the first set, I'm going to have 2x plus 2 In this one I have x minus We've seen 3 of these now. How many people are feeling better after 3 than they did after 1? Yeah, the first time you see it, it's kind of like mind-boggling, and you're like, whoa, I'm never going to get that. Then the second time, you're kind of like, all right, kind of getting it. And then the third time, it's like you're feeling a little bit better. You're like, okay, I took something hard. I made it easy. I solved it like I always would. And then I put it back to be the way it was. Okay, last ones that we're going to do. We've only been factoring trinomials at this point. Now we're going to factor binomials. So a reminder to ourselves, when we have a binomial, we're looking for something called a difference of squares. A difference of squares is something that has a subtraction sign in it. So this thing, subtraction sign, gorgeous. And it's also perfect square numbers and perfect square variables, meaning I can square root everything that's in the question. Can I square root x squared? For sure. Can I square root y squared? For sure. This is a difference of squares question. Good news for us. We know how to factor it. To factor a difference of squares, you square root both things to give you x minus y. But you know, because you're clever, when you factor, you're supposed to get 2 binomials out of this. And the second one is x plus 1. It's always the opposite sign. That should have been a review from 2.0. The next question, that is a math 20-1 double question. If you look at this one that we did, x squared minus y squared, and you look at this one, 2x minus 1 squared minus 4 plus, y plus 4 squared, that looks a lot more difficult because instead of just x, it was this awkward little binomial. And instead of just y, it's another awkward little binomial. So what I'm going to do is I'm going to make this easy. I'm going to take something hard, find a way to make it easy. I'm going to say 2x minus 1 is equal to, let's say, I don't use y this time because they've already used the letter y. And I don't want to screw myself up. So I just chose another letter. If you want to choose Z, Z's a popular letter for people to choose. Feel free to choose Z. Use anything that you can easily identify. For instance, I would never choose the letter S because my 5s look like S's. I would also never choose the letter L because my L's and my 1s look the same. I'd never choose the letter O because O and 0 look the same. Right? Just pick a letter that sticks out to you for your writing. So I did M because I definitely don't screw those up. My other thing, I'm going to change it to be N. That's another thing I won't screw up. Good same thing? N for no, M for math. Yeah. That changes this question completely. Now I have m squared minus n squared. That's something I can factor quite easily. I can difference the squares that right off the hop. It's going to be m minus n, m plus n. But if I change something, once I'm done factoring, I need to change it back. So anywhere I see an m, I need to put 2x minus 1. Anywhere I see an n, I need to put y plus 4. So I'm going to write it right next to it. Instead of m, I'm putting 2x minus 1. Instead of n, I'm putting y plus 4. I'm going to do that all over again. These difference of squares questions just get kind of long, right? They look a lot harder than they really are. If you look, that thing looks long, right? It looks kind of scary. It's not that bad. The number one thing that people seem to screw up on if they get this far. Really, you've done all the Math 20-1 stuff. You've done all the new stuff. The number one thing people screw up on? This negative right here has to do with both things. It has to change the symbol on the 4. I guarantee you people will make that mistake. This negative sign goes to the y and the 4. I think the way you guys were usually taught it was the negative changes everything in the brackets next to it. So this becomes a negative y and a negative 4. Now that's a plus. I think that's usually how you guys see it. I like to describe it as that negative comes into both things in the brackets. Same difference. Once that negative has come into the brackets, now you can add everything up. Right? 2x can't go with anything. The minus y can't go with anything. And then I have minus 5. Negative 1 minus 4 is negative 4. The next set of brackets, I don't even have any negatives to worry about. So it's just going to be 2x plus y plus 2. And that's going to be my answer. The difference of squares ones, like I said, they're not that hard, but that little negative thing really seems to throw people for a loop. Alright, we're going to try another one.
Don't change it.
Don't change it yet. I think we have a couple more difference of squares ones to try. Only one? And then that's it for lesson? Oh, beautiful. So you will get some time for that. It's a little bit harder. That's a doozy. The next one's going to be a little more challenging. We're going to talk about why it's a little more challenging. Because anytime you can identify why something looks hard, it gives you a starting point to figure out what you're going to do about it. It's difficult when you come into a question and you go, that's scary, but you don't know why it's scary. If I look at this question, that definitely does look scary. I'm going to slide it up right off the bat because I know I got a lot of work ahead. You guys got your paper, you know, you can write smaller than I can. I got to write big. So, this thing is a difference of squares. It doesn't look like it, but it is a difference of squares. Notice that you have something squared and then something else squared. There's a minus sign in between. That should signal to you, all right, this has to be a difference of squares question somehow, some way. So what I'm going to do is I'm going to make that a difference of square question that looks a lot easier than that one, and I'm going to get rid of those binomials. I'm going to call x plus 2 equal to m. I'm going to say 2y minus 3 is equal to n. So I'm going to replace those things so it looks much easier. That looks like something we can manage. That is a question in the Math 10C practice book. I remember it because I just saw it. So it's even a question you've done before, probably a year ago. Again, difference of squares this thing. But before we try a difference of squares, what type of factor do I do? GCF, right? GCF, GCF, GCF. I can divide both of these by 2. So a 2 needs to come out front, leaving me with 16m squared minus 9m squared. If you didn't remember to do GCF, you couldn't have difference of squared that, because 32 is not a perfect square and 18 is not a perfect square. So you've got to take the 2 out first to even create this question to make it possible. When we factor that thing, we have 2. We square root the 16 to get 4. We square root the m squared to get square root the 9 to get not 9, to get 3. Square root the m squared to get n, and we do it twice. The second time the symbol changes. That's the difference of squares, right? You square root, square root, square root, square root. Now what do you do? What put it back. Change it back to the way it was. So it's going to become 2, 4. We're going to really make these things stick out. So I'm going to change my color. Because this is going to get a little bit intimidating. And nice colors help. So you'll see the replacements I put in blue so that they kind of stick out at you. I changed m to be x plus 2, changed n to be 2y minus 3. I just wanted to really stick out so you see where things are coming from. I'm going to do the same thing here. I like that one. Eyes up, volume down. Did you hear that? That was a good little line. I might use that. So I made all those substitutions, and you notice that question, like it looks big and scary, but it's really not. At this point, it's just going to be some simple multiplication and adding like terms. So this 4 has to come into these brackets. So I've got 4x plus 8. This negative 3 needs to come into those brackets. To become negative 6y plus 9. And that does it for my first big set of red brackets. Now I gotta do the second set of big red brackets where the 4 comes in again. 4x plus 8. And this time a positive 3 comes in plus 6y minus 9. Now we're going to combine everything inside those brackets. So I've got 2, I've got 4x minus 6y plus 17. 4x plus 6y minus that is my final answer. Now, we've talked about the number 1 mistake people make, which is that negative they screw up coming into the brackets. We talk about the number 2 most common mistake that I like to see, is that people do all this, touch this thing, they factor the crap out of it, and they get here, and what do you think they're going to do? I want to guess. Yeah, some people multiply the 2 in. Or some people multiply these things back together. Now, I'm convinced that it's hard. One of the hardest things to do in math is to know when to stop. Right? Like, when are you done this question? You're done this question once you've got 2 binomials, 2 sets of brackets times each other, and everything on the inside of each set of brackets is all completed and simplified. But people will get here and they will multiply these things together and they'll keep trying to go. And it's just because you weren't sure when you need to stop. When was this actually factored? Factoring is unmultiplying. I'm going to multiply this back together. I'm going to get myself right back to where I started.
Is that how?
You wouldn't. And the reason you wouldn't is because you would get this thing, but expanded out, as if they multiplied these all out. So you would get an expanded version of that first question. And it would be massive. And it would not be fun. Promise. Any questions? That's as hard as it gets for difference of squares. That's a very hard one. In fact, it has every trick you need to know in the book. So it's challenging.
Are you going to ever need to be able to answer one?